Hello, boys and girls. I am Sir Zamin.
And I'm Miss Raymond.
Welcome to Science in Daily Life. I trust that you are doing well and you are well prepared for today's lesson. Can you recall what we would have looked at in our previous class? Yes, we would have examined the properties of matter, and we would have stated that matter has physical and chemical properties. In today's lesson, we will be looking at physical and chemical change. But let us recap what is physical and chemical property.
Boys and girls, physical property is a characteristic of a substance that can be observed without changing the substance into another substance. For example, we would have looked at the carrot. When we had the whole carrot, it was a carrot. But then we began to cut that carrot into smaller pieces. We still had carrot at the end of the day. We also look at chemical properties. And when we talk about chemical property, it's basically a characteristic of a substance that can only be observed by changing it into a different substance. Simply saying, we do not have the same product at the end of the day.
So students, let us go straight into what a physical change is. A physical change is a change in a substance that does not change what the substance looks like. Examples of physical change would include a change in shape, a change in size, as well as change in phases.
Now, when we talk about change in phases, boys and girls, we're simply talking about melting. For example, we have ice being melted into liquid or water. You have boiling from liquid to gas. You also have evaporation from liquid to gas. And you have condensation, gas to liquid.
We can also have freezing, which is from a liquid to a solid. Sublimation, which is the process of changing from a solid to a gas. And lastly, we have deposition, which is a change from a gas directly to a solid.
Now today, we'll be looking at some physical changes. Let us demonstrate for you what or how physical changes might be caused or how it can come about. Firstly, we will start with cutting.
Definitely. So, boys and girls, pay attention to me as I demonstrate to you a physical change via cutting. So, we have here a piece of paper, and I'm going to be using scissors. We're looking here at a piece of paper. What happens when I start to cut it? Let us go. So I would have cut this paper into 3 pieces. At the end of the day, did the property of the paper change? Is this still paper? Yes, it is still paper. Hence, this is termed a physical change because at the end of the day, it is what we would have started with before cutting, paper.
Very good, sir. Now, boys and girls, let us look at crushing. Sir?
Oh, excited for this one, miss. Thank you. So I'm going to use my hammer. All right? So if you do this at home, just be careful not to break any of mommy glasses or stuff like that.
For
So
sure.
I have here a Christmas decoration. So let us see after I would have hammered it or crushed it, if the decoration would change to something else. Ready? 1, 2, 3. Bam. All right. So I would have crushed my Christmas decoration. Did it change to something else? Did it? Or do we still have a Christmas decor in my hand? It's just in a crushed frame of mind at this point, right?
Now, I know for sure, boys and girls, we might say, you know what, it's damaged. But at the end of the day, it's still a Christmas decoration. I can still see the pink glitters. And we can see the inside of it, but it's still the Christmas decoration. So we can say this just undergo or it went through a physical change. Now, boys and girls, let us look at bending and breaking.
Sure, and for that, I would demonstrate it by using a pointer. Of course, you can do this at home. So we have a straight pointer, and I'm going to bend it. The process of bending Did the pointer change to something else? Can you still identify this as being a pointer? Yes, of course you can. Let us now break the pointer. It's similar to cutting, right? But I broke it. We now have 2 pointers, or 1 pointer that was broken into 2. But you hear me saying the word pointer all the time because it still remains a pointer. Hence, we term it a physical change.
Good. Now, let us look at squishing. We have some Play-Doh here. Let us see Sir squish that Play-Doh into something different. Will it change or will it be the same?
All right, so we have a red. I'm just going to take a piece of this. So, let's get squishy. I haven't done this since what? Nursery school. Yeah. I'm enjoying it. Yeah. So I would have squished Play-Doh. Did the Play-Doh change? Is this something else? Mr. Riemann, this is same Play-Doh.
It is still the red Play-Doh. As we can see, the original, and we squished it and it became, the only thing that changed here was the shape of it. Now there is also grinding. I know many of us has been exposed to in classrooms chalk, and sometimes we'll crush those chalk into powder. Now, did the chalk change? Is it still chalk? Yes, it is. It just went through a physical change. We also have heating or cooling. For example, you have a block of ice, and that ice changes into the liquid. So we will use that for our own desire. Now, let us talk a little bit about some evidence that showed physical change. We can take a look at today's demonstration, and we can identify some of these items.
Yes, boys and girls. What would have occurred via the processes I would have gone through today? It would have change in shape, some change in form, change in size, and when Ms. Riemann was talking about heating and cooling, you would see what's called a change in phase. Now, this is always a physical change when you change in phase, okay? And lastly, you should know that physical changes are usually reversible, meaning we can actually get back at the end of the day. So for example, when I would have squished that Play-Doh, I could easily mold it back into that rectangular shape.
Very well. Now, boys and girls, let us talk a little bit about chemical change. What is a chemical change? Now, a chemical change is a change in which a substance is changed into a different substance. For example, it is not the same. It is not what you're beginning with or what you're starting with. It's something totally different. Now, let us have some examples or demonstration of chemical change.
Very well. Now, some examples of chemical change would include burning, rusting, tarnishing, decomposing, and polymerization. Of course, these terms, you will examine more of them as you go higher in your continuous grades in integrated science, even in our pure sciences, okay? But today, Ms. Riemann will actually conduct some experiment to show chemical change. Yeah, she'll be doing the little more fun stuff right now. As you can see, she has marshmallow, she has her incense, as well as nails.
Now, what I want you to do, boys and girls, is let us identify if we can actually have the same item after we're finished with these demonstrations. So I'll start with the marshmallow first. As you can see,
She's making us hungry, right, students?
now, boys and girls, take a look at your marshmallow. I just put it over some flame or the fire. Do you think I can get the exact marshmallow that I had before? No, I cannot. So this marshmallow it went through a chemical change. Let us now look at the incense. Some of us, or most of us, would have incense in our home, or we can simply light a matchstick. What do you think will happen with the incense? Let us take a look.
Yeah, let's have some sweet aroma in today's class.
Now, you can see some smoke here. But what do you think will happen? And I'm pretty sure most of you boys and girls would say, you know what? Or your mom would tell you to be very careful with incense, or sometimes you're asked to clean up after the incense is finished burning. Now, what happened, or what you would find after this incense is burned, is that you will have some ashes on the ground. And you will see that by the end of the lesson. Now, can we get the same property or the same incense as it is? If that is the case, boys and girls, no, we cannot, because it underwent or undergo chemical change. We cannot get the exact property or change.
Definitely, miss. Let us now demonstrate burning paper.
Definitely.
Go right ahead.
So, boys and girls, I have a piece of paper. Now, I need you to be very careful. Do not try this at home without an adult supervision. And ensure when you're doing anything with flame or fire to be or wear your protective gears, or try to be very cautious with it.
Definitely.
So, boys and girls,
wow.
what just happened there? Take a look at this. We have our paper and we have some ashes next to it. Can we take the ashes and get our paper back as it was? No, boys and girls, we cannot. So this paper, when we put it over the flame, it went through a chemical change. Now, boys and girls, let us talk a little bit about the evidence that shows chemical change.
Okay, boys and girls. So some evidence that would show that a chemical change has actually occurred are a color change, an odor change, gases formed, as well a change in the physical property. So like the physical property, when you could have gotten back what we'd have started with, in the chemical change, you cannot get back what you would have begun with in the first place. All right?
Very good. Now, boys and girls, during a chemical change, and I'm pretty sure you would have observed that for yourself too, energy can be released in the form of heat and light. It was visible to you.
Yes, especially in today's lesson, it was extremely visible with lighting the incense stick as well as the paper.
Good. Now, boys and girls, do join us for another lesson on energy. My name is Miss Freeman.
And I am Sir Zamin.
Bye-bye.